This is the Tech Collective, and I'm going to today show you how to make your test circuit for the Wii Nunchuk. I already have my Wii Nunchuk plugged in, as you can see. The first step we're going to want to start with is plugging in our GND or ground wire into the GND port right here on your board. You're going to want to take that and plug it into your rail, this rail. Has a minus on it. You're going to want to take next your first LED. I'm just going to start with green. You can start with whichever one you have. The long is positive and the short is negative. I don't know. This is long, this is positive, and this is negative. As you can see, their sizes are different. You're going to want to plug the negative into the negative rail and the positive into the breadboard. Next, we'll do our red one. Same idea. I like to space them out by one area. So now that we have our LEDs plugged in, we're going to want to take our resistors and plug each resistor. These resistors are not, it doesn't matter which way you plug them in, they'll work either way. And we're going to plug them in to bridge this gap. Like that. You're going to do that for each of your resistors. Now, it might look a bit different on your circuit, but as long as you have them lined up, it'll work. Okay. Next, you're going to want to take, we have somewhat color coordinated jumpers. You're going to want to take your jumper, and for the green LED, we're going to plug green into D5. We're going to plug red into D4 right next to it, and then yellow into D3. So your pins, all of your pins will be D3, D4, and D5. Now your circuit should be complete. Or you can plug it in now. And you should see your lights come on.
Hello and welcome to the first of our Arduino microcontroller instructions. What you see in front of you is an Arduino Nano, which is the blue board right here, sitting on top of a breadboard, which is this white board. Now we use this setup to do prototyping for different types of circuits. It's nice because we do not need to solder. We can just use jumper cables to simulate the different connections to test the circuit. Once we're sure the circuit is working, we can come back in and solder the circuit to create the final product. Now with the breadboard, let's first discuss how electricity flows. There's two main areas you need to look at. On the end here, we have sections which are labeled plus and minus. And you'll notice I have a black cable plugged into the minus, which, as we all know, black and minus always mean ground. Now the way this works on a breadboard is every pin along this rail is now a ground pin because I have it hooked from this black line into the ground port right here on my Arduino. Now, conversely, if I hooked a voltage port into this red pin, all of these pins down this row would be a voltage. Now in this experiment we're working on in this circuit, I don't need voltage, so we're not hooking anything up to that. But always remember, on our outside rails, one on that side and there's one on this side, the electricity always flows, or the conductivity always flows lengthwise like this. These two pins right here do not share common polarity or common circuit. Now, conversely, if I look at my number 1 here, and I have it labeled A, B, C, D, E along the top, these pins, 1, 2, 3, 4, 5, 6, etc., electricity on these flow horizontally, we'll call it, like this, on our x coordinates. Actually, I guess from our reference, we are y coordinates. So if I plug something, in this case, I have an LED plugged into this port. This piece of electronic is called a resistor. They are sharing, or they are on the same channel. And so electricity will flow through my ground port right here. You can see it down there, through that ground pin. It'll come over to this pin. This pin will then make all of row 7 work. So then I'm taking it from the next pin here in row 7. I'm jumpering it over to the pin on the other side, which is still row 7, into this jumper cable, this yellow jumper cable, which is then jumping it all the way back. And I have that going into my port D3 right there. You see that one? It's kind of tough. So with breadboards, always remember the way and the direction that the electricity is flowing. The final piece to remember is this center channel here is a break. So these pins from port 1 are all tied together, and these pins from port 1 are all tied together. But they do not cross over this middle unless, as you can see, as we've done here with this resistor, we jumpered them over. So in this case, I've jumpered that channel over, and I've made this side now also conductive. A last quick piece I want to talk about is about the circuit. Remember, a circuit stands for circular. And so any circuit has to be a circular flow of electricity. If I follow my circuit from my ground pin, it goes up and over through my ground, it comes, it hits my ground pin on my LED, comes back, jumpers to my resistor over to my green cable up and over, back into my board into port D5. I have a circular system there. Now, something I've added is I've added multiple circular circuits. We call that a series because these are in series. And so we have multiples. If I remove one, the others will continue to work. On the back side here, I've got some more pins as well. Let's quickly talk about the pins of the Arduino Nano before we move on to this circuit and how it's working. The pins on the Arduino Nano, some of the important ones you need to remember, these say D, 3, 4, 5, 6, 7. They're numeric. Those are our digital pins. Those usually are on or off. On the other side, these are A, or for analog. And remember, analog can store a value or a range of values. So it's not just on or off. And so I have A1, 2, 3, etc., etc. G and D is for ground. VIN, another important one, stands for voltage in. If I did not have this connected to my USB port, I could plug a battery directly into my voltage in and my ground, and it would power this Arduino as long as the voltage of the power source was correct. Over here, I have one that says 3V3. That means that's 3 volts out. This one here says 5V. That means it's 5 volts out. And let's see, a couple over here, TX, RX. Those are for serial communication. We're not going to talk too much about those yet. But I think that's about it for the basic overlay of the breadboard, the Arduino Nano, and how we use jumpers in a breadboard to create a circuit. We'll be back shortly with our second video to describe how this circuit is working. Welcome back to our introduction to basic circuits and electronics with the Arduino board. Now let's talk about the circuit that we have here and what its purpose is. I've zoomed out a little bit so you can see it a little bit better. We also have connected to the bottom half here our nunchuk that we're going to be using to control our ROV. We'll show that in a little bit. I have 3 LEDs, a green, red, and yellow LED connected. And I've got those going to yellow, orange, and green jumpers back into my Arduino board. Now in another window, we'll show the code that's currently loaded on this Arduino board and how it's operating. First thing, I'm going to go ahead and I'm going to plug in our Arduino board to my power supply. There we go. Now you're going to notice some lights here come on as it boots up. Only takes a second or two, and then it will start operating. Now, once we've got it operating, obviously looking at it from this, you really can't see anything happening. It's just doing its thing. That's why we have the LEDs. Another component we use, which I'll show you on a computer screen, is we use something called the serial monitor, which will show the data that is coming and going in and out of the microcontroller. Now, this circuit is very straightforward. I have 3 pins that are set up to send a signal out to these LEDs when something happens. It's called an if statement. So if the value of something happens, then you're going to turn these on. And that's all it is. So let's go ahead and look at that really fast. I have my nunchuk controller, and I'm going to go ahead and push a button. Now you notice the green light comes on as long as I hold it down. Push the other button, the green light comes on. So all I'm having it do is it's reading down here on this side all of the data coming in from this nunchuk controller. And I have an if statement saying if the button gets pressed, turn the light on. Now we're going to equate that to our motors. It's the same concept. If the bottom button gets pressed, you're going to put a negative voltage into the motor or make it go down. If the top button gets pressed, you're going to put a positive voltage into the motor and you're going to make it go up. Remember, motors are bipolar. So depending on how we send electricity to the motor will determine which direction it spins. Now, with that understanding of how this is working, we'll go and look in the code in a second. The joystick works exactly the same. When I turn the X axis, the yellow light comes on. When I release it back, it goes off. On, off. Now, there is a difference. The buttons are, by nature, either on or off. They're either pressed or they're not pressed. The joystick, however, does have analog data. It has a range of values that it can record. In this case, I have changed it so that basically I'm at the very extreme of those values. So if I go anywhere in between, it won't come on until I hit the very edge, and then it will come on. Now the same concept with our Y. If I go all the way to the edge, our red light comes on. Now you say, why would you do a circuit like this? What's the purpose? This is a great way to test the code of the Arduino and to understand that data is passing and working properly before you start connecting it to motors and running into problems. I know that my code is working. I know that it's triggering properly for the different channels. So the next thing I would want to do is just make sure that the down is going down and the up is going up, or vice versa, left is left, right is right. So that will be the other purpose. You could add another bank of LEDs and just say if it was up, for example, or if the value of this pushing up was a certain range, turn the light on. Remember I said if, thus an if-then statement. And we'll show that in the code. So I'm going to quickly press it, and I'm going to equate it to what's happening on the computer side of things. The final video in discussing our nunchuk controller with our Arduino Nano microcontroller. Now in this video we are going to look at the behind the scenes and go over the code briefly that we're using for this controller. This is the Arduino development environment. This is what the code looks like. And we're just going to go through some of the major items of the code and then show it in operation. Beginning, we include what are called libraries. One is called nunchuk, which controls the nunchuk controller. Another one is called wire, which controls the I2C bus, which is how we communicate with the nunchuk controller. INT stands for integer. That's a value that we use for a variable. And we've got several of these: value for the Y, value for the minimum Y, accelerometer, a center value, and then the last three we've got, which are important to note, are LED for X, LED for Y, and LED for B or button. And 3, 4, and 5 are the pins, as you remember from our previous video, that we have those plugged into. Now, variables do need to be defined to store the data that we'll be using later. We quickly define the nunchuk and the SDA and SCL ports. This is how the data comes into and out of our Arduino. In every code that we're going to be doing with an Arduino, and in fact most programming languages, there are at least 2 what we call functions. One is called setup or void setup, This is run the very first time the device boots up. It's run one time only, and it kind of gets all of the hardware prepped and ready. In this one, we're going to turn on the serial device or the serial monitor so we can see data coming and going. I turn on my 3 pins that I'll be using for my LEDs, and I set those to a type output. This means that I will be pushing voltage out of those pins as opposed to input, where I will be reading data from those pins. For example, if I had a button or a dial, I would want to read or have an input. In this case, they will be output. I begin my nunchuk controller. This is part of the library. And now I have a few if-then statements, or in this case, these are actually if-else statements. All these are doing is calibrating the nunchuk because there are several versions of the nunchuk. Some use different accelerometers, and some use different joystick. This will set the range at which the data will be read. Once we finish with the calibration, then we move into the main loop of our program, void loop. Void loop is what will loop over and over and over again and run the main body of our program. Very straightforward what we're going to do. We're just going to briefly go down the lines, and then we're going to look at the actual data that it's producing. We're going to read the data from the nunchuk. We're going to print a line of inputs to the serial monitor, showing what all of the values are for the joystick, the accelerometer, and the button status at that exact time and moment. We're going to then set some of the values in our variables to those values. We're going to get the joystick Y or X coordinate, put it in value X. The Y coordinate, put it in value Y. Same thing for the accelerometer, same thing for the status state, of the buttons. Now, Boolean, B-O-O-L, just a brief, we've already talked about integers, those store numbers. Boolean stores true or false, 0 or 1. So either a button is on, true, or it is off, false. Okay. The next thing we do is very straightforward. It's just a set of if-else statements. We're going to check first the value of the X on our joystick. If the value of our X is less than 2, or, that's what the 2 lines designate, the value of X is greater than 253, you're going to turn the LED on, or turn it to high. Else, otherwise, turn the LED X to low, or off. We'll do the same thing for the Y joystick. If the Y value is less than 2, or the Y value is greater than 253, you'll turn the LED on, else you'll turn the LED off. The final thing we're going to check are the buttons. If the button Z is greater than 0, remember this is a Boolean, so 0 would be false, 1 would be true, or button C is greater than 0, turn the LED on, else turn the LED off. Now, I'm going to bring up our serial monitor, and we're going to discuss those values. So here we have the joystick X. When I move my joystick X to the left, my value becomes 1. So when my value becomes 1, when I'm checking value X is less than 2, 1 is less than 2, it's going to turn my LED on at that time. Same thing, when I go to the right, it becomes 254. 254 is greater than 253, so turn it on. Now, we'll do the same thing for Y. 128. Now, this one goes to 0, which is interesting, but it's just a part of the physical nature of this circuit. But that is still less than 2, and so we'll turn it on. Same thing with my up. This goes to 255, so turn it on. The last thing I have are my buttons. If either of these show turned on, like the C button right now is being pressed, or the Z button is being pressed, turn it on. Now, obviously, I can do all 3 at once, and all 3 LEDs will come on. I can push diagonally on the joystick, which makes both my values read true in my if statement, so both of these are going to turn my LEDs on, and then I can push a button to also turn an LED on. That's a quick and simple explanation of how the code is working and how the data is being read by our microcontroller and how we're using that to turn LEDs on and off. Once again, think of these LEDs as turning on and off a motor. That's basically all we're doing, is when you push forward, you need to turn a motor on. When you push backwards, you need to turn a motor on, but you need it to spin backwards. So that's the thing we will be adding, is how are we going to change the direction for forwards and backwards. In this case, we're just checking the values to make sure the data is accurate. That is everything.